Hi class, I recorded this video last week and it turns out that the battery was dead on the microphone. So I am playing it here in Media Player and I'm just going to narrate over it. So if the timing seems off a bit, that's why. We have here a pretty classic example of a depreciation problem with a vehicle losing its value every year. So it starts out worth $14,000, so that's going to be our value for A. A is the start value in the exponential formula, y equals ab to the x power. In part A, they want us to find the value of the automobile after 2 years. And it says that it depreciates by 1/5 of its value every year. Since it's depreciating by 1/5, it's retaining 4/5 of its value from year to year. 4/5 is 0.8. So basically the car is losing 20% of its value and keeping 80% of its value. So that's why B is 0.8. X is what we're going to plug in for, and here it's going to be 2 for 2 years. So we just calculate it and it comes out to be, here it comes, 14,000 times 0.8 to the second power. $8,960. So that is the value of the vehicle after 2 years. For part B, they want us to find out when the automobile is worth half its initial value. So we're going to find its half-life. So to do this, what we're going to do is we're going to take the equation 14,000 times 0.8 to the x and set it equal to half of $14,000, which is $7,000. So that's what the other side of the equation is going to be. In this problem, we're solving for x, and x is the exponent. These problems are a little more difficult than any of the other problems we've worked on this year because the missing variable, x, is the exponent. We're going to learn some other techniques later this chapter called logarithms, using logarithms to find x. But for now, we're going to use the technique that I'm about to go through. The first thing you want to do is divide both sides by 14,000, and that'll get 0.8 to the x by itself. So you want the base and the exponent to be isolated. Anything surrounding it, like something multiplied or added or subtracted, you're going to want to get rid of by doing the opposite or inverse operation. At this point, we have 0.8 to the x equal to 0.5. So we're going to find the missing x by using our graphing calculator. What I want you to do is go to y equals, on your calculator, and put in 0.8 to the x power for y1, and for y2, put in 0.5, which is the value that you want it to reach. When you graph it on a standard window, there's your 0.8 to the x, and then you're going to have a horizontal line coming across at 0.5. When we find the intersection of these two functions, so second trace, option 5, enter, 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 you'll see that they cross at 3.1 years. So it takes 3.1 years for this car to depreciate to half of its original value. So that's it for this example. Hope you liked it.